Okay, let's try to do another exercise. Okay, so firstly is to determine where is the terminal for the BJT. Always remember, okay, at the arrow is the emitter part. Here is the base, and another one is collector. So here your input, okay, the input is connected to emitter, and the output is at collector. Okay, so now let's draw the equivalent circuit for this. So input, I like to draw input on the left. Input is emitter. On the right is output. So this is collector. And we have base. From base to emitter, we have R pi. From C to E, we have a current Gm V pi. Okay, so this is from, the arrow is from C to E. Okay, so this emitter is NPN type, okay, because here is the base is positive and the emitter is negative. Alright, and then what you need to do is you find what is the component that connected to the input. Okay, so here at the base, at the emitter, we have RE to the ground. And then we have RS, VS. Okay, at the base, over here you have base. This is R1 and R2. For R1, it goes to the ground, right? R1 goes to ground, and then R2 goes to ground, and then there is a capacitor C3 over here from base to the ground. Okay, so what happened here? Okay, here if you see from the base, the C3 is bypass base to ground. Therefore, R1 and R2, okay, no longer current will flow through it because the current will find the easiest way to flow. Okay, so we can eliminate R1 and R2 from our circuit so that we don't get confused. So we complete R1, R2, C3, and then at collector part we have RC goes to ground, and then we have RL goes to ground as well. So here we have the out. Our Z out is before RL pointing to RC. And then our ZI is pointing to our RE. Alright. Alright, now how to determine ZI. Okay, so here you can see ZI is parallel with R pi. Yeah, we see RE with naked eye, we see RE is parallel with R pi. However, here the current flow through RE is IE, and the current flowing through R pi, current over here is IB. So there is a huge difference between both currents. So we cannot directly parallel the resistor like this. Okay. So here what we can do is for this R pi, okay, we need to find the equivalent resistance. Okay, the equivalent resistance through for R pi. ZB, okay. So ZB here, if you refer to my notes, it will be equals to R pi divided with beta plus 1. Okay, therefore your ZI is RE parallel with ZB. Okay, you can also use a normal configuration for your BJT like this. Okay, base on the left, collector on the right. However, here, okay, here for your ZI, you see your RE is also connected to R pi. Okay, so here also correct way to draw your equivalent circuit. Okay, however, here you need to ZI is equivalent to RE parallel with, because the current is different. Okay, the current difference at IBN. IE, you need to parallel it, the R pi, you need to change it to equivalent resistance. Okay.